So this video is going to go over the difference between what we call independent and dependent events when we're studying probability, and then we'll look at how they differ in finding their probabilities. So I have a couple of examples here that we'll just look at first. So this first one says picking 2 cards from a deck without replacement. So this is really important. This would mean that you're taking a card out of the deck, not putting it back, and then picking again. So since the chances of any one card being chosen are now going to change, since that card's missing, we would call these dependent events. So anytime you see anything to do with without replacement, not putting it back, something along those lines, it's always going to be dependent. Okay, if you flip a fair coin 2 times, so if you can imagine flipping a coin, whether I get heads or tails, on the next flip, it's the same chance, still 50-50 of getting either flip, so we would call these independent events. We don't have to experiment with a coin to know that that's true, as long as it is, they specify here that it's a fair coin. Spinning a spinner with 3 equal sections twice. This is kind of similar to the coin, right? If I spin a spinner with 3 equal sections, all of those sections, you have a 1 in 3 chance of landing on them, and it would be the same thing on every spin. It wouldn't matter how many times you did it. So this would also be called independent. And then it says picking 2 light bulbs to go into 2 rooms. Well, since they're going into 2 rooms, meaning you pick a bulb, it's going to get put in a socket, and then you're going to pick another one of the light bulbs is gone. So even though they don't come right out and say without replacement like they did in that first one, there's enough information here for you to tell that these would be dependent. Okay, so that's just kind of figuring out, just by kind of thinking, using logical common sense and what we know the definitions of these words are. Now we'll look at how this affects probability. Okay, so in this first example, it says Johnny has a bag of cookies. 3 are chocolate chip, 4 are sugar, and 2 are peanut butter. What you might want to make a note of right away is how many cookies there are in total. So 3 plus 4 plus 2 means there are 9 total cookies, so that'll help us out. Okay, so it says find the probability that he picks 2 of the same type of cookies. Okay, well that could happen really one of 3 ways. This would mean 2 chocolate chip, 2 sugar, or 2 peanut butter. And so we're going to have to consider all of these options when we find our probabilities. Now another thing we want to notice is they said that he's going to pick the cookies and eat them, meaning that this is going to be dependent events because one of the cookies will then be gone. So the fact that he's going to eat the cookies after he picks them makes this dependent events. Okay, so if he reaches in blindly and picks a cookie, the chance it's going to be chocolate chip would be 3 out of 9. And then if he reaches in again, since that one's gone, there would only be a 2 in 8 chance that he gets chocolate chip on the second one. So that takes care of my chocolate chip scenario. Now if I think about sugar, again, if he's blindly reaching in for the first time, there's a 4 in 9 chance that it's a sugar cookie. And if he reaches in again after he's eaten that one, now there are only 3 sugar cookies left and 8 cookies total. And so finally, peanut butter, same idea. If we're starting over, the chance he picks a peanut butter blindly is 2 out of 9. And then once he eats that cookie, it would be 1 out of 8. 1 fewer peanut butter and 1 fewer cookie. So now I'm just going to put this whole thing in my calculator, and we'll see what we get. So that first situation came out as 4 over 27 when I reduced the fraction. Now I'll put in the second one. That comes out as 1/6. And now finally I'll put in the third. That comes out to 1 over 36. So these don't all have the same denominator, so I'm just going to go ahead again and add them in my calculator. So I'm adding 4 27ths plus 1/6 plus 1/36. And again, it didn't talk anything about rounding, so that means I'm going to just math fract this, and I get 37 out of 108 as my final answer. I'm just going to squeeze this down here. So that's the final answer. So the probability of picking the same type of cookie 2 times. Okay, part B says, it's a little bit more specific. It says, what's the probability his first cookie is chocolate chip, and then that the second cookie is peanut butter? So in this situation, because they're specific about the order, we don't have to consider multiple situations because they've really only given us one type of scenario for how this could pan out. So the probability that the first cookie is chocolate chip, again, if we're starting this over, there are 3 of them out of 9 cookies total. So that would be my first one, and then I'm going to multiply that. If I go now for peanut butter, there's still 2 peanut butter total, but there's only 8 cookies because one of them's gone. So I'm multiplying 3/9 times 2/8. And when I math fract that, I get 1/12. I'm not leaving any of these as decimals because it didn't say I could round, and all of the decimals are coming out where they would need to be rounded. So that's why I'm just turning them all into fractions. So that was an example of looking at a few different probabilities where we're dealing with dependent events. In this second example, it's talking about rolling a fair die twice. And then we have a couple of probabilities. So this is kind of, if you remember those first few examples we looked at, it's kind of like flipping a coin or spinning a spinner. Every time we know that the same probabilities are going to be for all of the events. Nothing's going to change from one flip or one roll or one spin to the next. So in this case, we're dealing with independent events, which means we won't have to worry about changing our denominator at all because we know that the total number of possible outcomes are going to stay the same. So the first one says to find the probability that your first roll is an even and your second is a 4. Okay, so we just have to look at these two events on their own and multiply them together. So the chance that you roll an even on a fair die would be 3 out of 6. And rolling a 4 on your second would have the same denominator of 6, and there's only one 4 on the die. So I'd be multiplying 3/6 and 1/6. Again, I'm going to have to math frac this because it comes out as a long decimal, so I do get 1/12 again. Okay, then it says you roll an odd number both times. Okay, well again, there's not really a way that we could do this in any different order, or just an odd number and then an odd number. There's nothing more specific about it. So in this case, the chance of rolling an odd would be, there's 3 odds out of 6 outcomes, and it's going to be the exact same chance on your second roll. So I'm really just multiplying 3/6 by 3/6. And I get, you could leave this one as just a nice terminating decimal, so you could leave it as 0.25 or 1/4. Okay, and so that's it. That would be an example of doing probability questions with events where you have to first decide if they're independent or dependent.